Hello everyone, my name is Xiaolei and I'm from NetESCI AI Lab, Hongbo, China. It's my pleasure to share our solutions, which won the second place in the KDD Cup 2022 ESCI Challenge Task 1 and also obtained competitive results on Task 2 and Task 3. In this challenge, the organizer provides the shopping queries dataset, a large dataset of difficult search queries and products with ESCI relevance judgments. ESCI means exact, substitute, complement, and irrelevant. The dataset is multilingual, including English, Japanese, and Spanish, giving a user-specified query. The task 1 is to rank the products by semantic mention. Task 2 is to classify each product as being an exact, substitute, complement, or irrelevant match. And task 3 is to identify the substitute product. There are many different pre-trained language models for the three languages, and multilingual versions as well. We adopted 4 pre-trained language models as our basic models through experiments, and they are Robot Large, Microsoft Debater v3 Large, Microsoft M Debater v3 Base, and XM Robot Large. The overall architecture of our method is shown in this figure. The first step is to obtain semantic representation of query and product by fine-tuning a pre-trained language model, where we use Robot Large and Debater v3 Large for English, and Debater v3 Base and XM Robot Large for Japanese and Spanish. Then we feed the last hidden state of the pre-trained models into a BI-LSTM layer. Then the output of BI-LSTM is fed into the dense layer to get the prediction. For task 1, we use MSG loss, and the 4 categories are mapped as 1, 0.1, 0.01, and 0. For task 2 and task 3, we use cross-entropy loss function. Here are some results of task 1. We trained all the models by 5-fold cross-validation. Using this method, an ensemble of debater and roboter can get 0.9019 on public test set and 0.9 on private test set. A second phase of pre-train in domain leads to performance gain. In our methods, we continued to pre-train XM Robot Large and Robot Large using the competition dataset and achieved better results in task 1. Specifically, we continued to pre-train Robot Large using English dataset and XLM Robot Large using all 3 languages dataset combined. In this way, we can use not only the trained dataset but also the product information that do not appear in the trained dataset. For the final submission of task 1, we trained several different versions of the models and apply weighted average to get better ensemble result. The details are shown here. There are 4 debater large models and 4 robot large models trained on English dataset, 2 MDebater models trained on Japanese and Spanish dataset separately, and 5 MDebater models trained on Japanese and Spanish dataset combined, and 5 XLM robot large models trained on all the 3 language datasets. Due to limitation of time and computation resources, we only use 3 of 5-fold task 2 models for final submission and 2 of 5-fold task 3 models. Here are some training strategies that we used. First, we freeze embedding parameters during train freeze. We also use different learning rate for debater large models. The learning rate should be lower, and the output layers like dense layer and LSTM layer, we set a larger learning rate for faster convergence. In addition, we use linear schedule with warm-up and 5% warm-up steps. It should be noted that during the inference phase, we speed up the model inference by PyTorch AMP and pre-sort input test according to the token length. On task 2 and task 3, we use multitask learning and achieve about 0.1% to 0.2% improvement on local validation set. In task 2, we jointly train 4 two-class classifiers while training the main 4-class classifier. In task 3, we jointly train the 4 classifier and the classifier of substitute label. The loss functions are following. In this part, we want to share some ideas that we tried but did not use in the final submission, hoping to provide some useful insights. We experimented with translation and text generation to augment the data. Specifically, we translated the Japanese and Spanish dataset into English, and also trained a BART text generation model to generate query from product title and bullet point. But this method didn't work due to the extra noise probably introduced. We also tried to extract keywords or key sentence of long texts, such as bullet point or description, but this didn't give us any improvement. And the cross features. The dataset consists of query product pairs, and there are some products that appears in different queries, which we believe should be useful. As shown on the left of this figure, product P1 appears in queries Q1 and Q2. So Q2 should be used for supplementary information when predicting Q1 and P1. Similarly, we can obtain associated queries for each product, and it should be noted that these queries must only be obtained from the trained dataset to prevent label leakage. Through this method, we achieved more than 0.1% improvement on the local validation set, but not much improvement on the public leaderboard. In the end, we only used this feature in the submission of task 2. Another cross feature is shown on the right of this figure. Through data analysis, we found that among all pairs of same query, the brand name with the most occurrences is more likely to be exact, such as B1 in the figure. However, we did not have enough time to experiment this feature in our methods in the end. We also tried pairwise loss, but it did not work well. Compared with MSE loss, it's slow to converge and quite sensitive to noise label. In this challenge, we found that given a query, the more non-exact categories in the candidate products, the lower the NDCG score is likely to be. These query product pairs can be considered as hard cases. The intuition of post-processing is to pick out these hard pairs according to the score distribution predicted by stage 1 models, and then train up stage 2 models with the query and product titles of multiple pairs. An example is shown in this figure. Ultimately, we did not achieve higher NDCG score than stage 1 model in this way. So we think maybe better modeling methods and more experiments are needed. So that's all. You can find more details in our report. Thank you.